All right, so let's talk about, for the first part, what does it mean for, let's see, we've got 5 points, and we want both dy dx and d2y dx squared. What does that mean? Second derivative, right? So this wants the first and second derivative to both be negative. Which point on the graph illustrates both of those things? So just staring at it is like, well, you're asking me about the first and second derivative, but you've only given me the original graph, or f of x. So how the heck am I supposed to know that? So what you're going to do with dy dx, if dy dx is negative, what does that imply about, that looks like a smiley face, doesn't it? Sorry. What does that imply about the original function? What is the original function doing if the first derivative is negative? What's it doing? It's decreasing, right? Do y'all remember that? The function has to be decreasing if the first derivative is negative. So f of x is decreasing. Well, let's look at our points, just examining that. Well, look at point A. Is f of x decreasing at point A? No, so it can't be point A, so answer choice A is gone. What about for B? Yeah, the original function is decreasing there, so B is a possibility. What about C? It might be, might it? Because your function still seems to be decreasing a little bit there, so I wouldn't completely throw out C. What about D? What does it look like my derivative should be at D? Y'all are whispering, I can't hear you. What does it look like? What could I draw there? A tangent line? What kind of tangent line? Horizontal. And so if it's a horizontal tangent line, what does it mean about the derivative's value? It's 0, right? So if it's 0, can it be negative? No. So I would toss out D. Now what about E? What's the function doing at E? Increasing. So let's look. What are our only answer choices left? B is a possibility. C is a possibility. D is no longer a possibility, nor is E. Do y'all see how we just gave ourselves a 50-50 shot with this? Please, please, please. And again, this is something we all know, right? That's not news to y'all. Groovy? All right, now what does it mean? Let's look now for the second derivative. If my second derivative is negative, what does that imply about my original function? What is f of x doing? What is true about f of x? Concave down. F of x is concave down. That's a C, not an E. F of x is concave down. Now, if you said, heck, if I know what color of paper that I've given y'all, what do y'all need to go back and look at? Do y'all remember what the sheet was that I had all that on there? What color was it? Pink? So y'all go back and look at that pink sheet. I think it was pink. It might have been green. I don't remember, y'all. Blue? No, that's going to be all of your theorems. Let's see. What is that one? The green one. Taylor, hold that up. That has all this information on it, right? Has every bit of it. So y'all please go review it, because these questions are not that difficult and they don't require a lot of algebra. It's just learning all those facts about the first and second derivative. Okay? So what would have to be my final answer if f of x is concave down? Is it going to be B or C? It's going to have to be B, isn't it? Because here we are concave down, like a frown. Okay? Questions? Questions, questions. All right, let's go to the next one. Right here, the graph of the function f is shown in the figure above. So here, you've got the original graph. For which of the following is f prime? Oh no, now we're talking about the derivative. F prime positive and increasing. All right, so let's talk about it. If f prime at x is positive, again, what does that imply about my original function? What is f of x doing? F of x is what? Increasing. Awesome. So let's look at our points. Which points can I go ahead and eliminate based on this fact? A can be eliminated, right? Because what is my function doing at A? Decreasing. So what about for B? Is my function increasing or decreasing there? No, it's really not. So let's chunk B. What about at C? Is my function increasing? Yeah, my function is increasing at C, isn't it? Okay, what about at D? Nope. What about at E? Yes. Okay, do y'all see how we're doing that? Awesome. Now, let's look. It's also saying that f prime at x is increasing. Well, f prime at x is increasing. Let's think about a few things there. If we knew our original function was increasing when the derivative was positive, well, f prime at x increasing is going to imply that f double prime of x is positive, right? Because it's just the derivative of the derivative. If your function's increasing, then its derivative is positive, right? Well, what does that tell me about f of x if f double prime is positive? What does it tell me f of x has to be? I can't hear. Concave up. F of x has to be concave up. So here, f of x is concave up. So which answer choice do I need to choose? Is it C or E? E. Okay, questions about it? Any questions? Right, again, what are we given the graph of? Always go and see. We're given f prime, right? We're given f prime. So the graph of f prime, the derivative of f is shown. F has a local maximum. Local maximum. That's the same thing as a relative max, isn't it? Okay. So where in the world would my original function have a relative max when I'm given the graph of f prime? Well, let's think about this. F has a relative max. Do y'all remember writing all this mess? When what happens? When what happens to our derivative? When f prime does what? Good. Changes from what? Positive to negative, right? So where does that occur at? It occurs right here at 1, doesn't it? So my answer choice is C. Grooves, you good? Questions? All right, let's continue on. Oh dear goodness, one of those. Crackhead teacher had to put one of those on here, right? Okay. At the end of the day, no matter what is that asking for you to do? You got to find something. At the end of the day, when you summed all of this up, what was this saying? What is this the definition of? Derivative. This is the definition of a derivative, isn't it? So this means you've got to take the derivative of something. See some confused looks. Let's talk about what was that definition. Do y'all remember, let's say the limit as h approaches 0 of f of x plus h minus f of x. What was all that crap over? H. Right? Does that kind of strike a chord now? And that's where you're forcing, h is the distance between your 2 points, and you're wanting that distance to become 0. So your secant line then becomes a tangent line. Okay? So let's ask ourselves, because we had a couple of things we would look for. One thing, do you see an x value up here? Well, you don't see just x itself. What does it look like x is going to be equal to? 4. Awesome. What does it look like if I say, okay, I really should have x's here? What does it look like my function should be? Remember, f of x is sitting right here. So what does it look like my function is? Natural log of x, isn't it? Okay. Y'all see that? Y'all remember now? Good. Now, what's the derivative of the natural log of x? 1 over x. Awesome sauce. So that's 1 over x. And so what am I going to get when I let x be 4? 1/4. So the answer is B. And I know that's tough. A lot of people get stuck on those, and I understand. But y'all will see one of these on every review quiz until the percentage hits about 80%, because that is going to be there. It's going to be there. If it's not there, if y'all come back in May and say, Ms. Rob, one of those problems wasn't on there, I will just be like, dang, they fooled me. Because I really think it's just, they're always there. But this could be the year they don't put it on there. But according to their patterns, it will be. Questions? All right, let's shake and bake on this one. Hey, here's another one. This wants us to take good old-fashioned derivative and plug in 1, right? So what would be the derivative of this function? So that means that f of x equals what? Let's see, derivative of each part, because this is a polynomial. You've got each part divided up by plus or minus. So the derivative of 7x is 7. What's the derivative of 3? 0. And then plus, what's the derivative of the natural log of x? 1 over x. And now, oh, I didn't do my prime. So what is f prime at 1 equal to? 8. There's my answer. Oops. Okay, questions? All right, we'll keep it trucking then. All right, so number 6. Okay, y'all look at number 6. You're asked for how many values in the open interval is f discontinuous. And the most common wrong answer that was given was D. Yeah, that was the most common wrong answer. What is the correct answer? C. The correct answer is C. Now, the fourth, here's a couple of reasons why I think people chose 4, is because they counted this right here as 2 different points of discontinuity. What is the x value there? The x value is not different, is it? So there's one place of discontinuity. Another reason some people, and this is what another class said, was they were thinking this right here. You are continuous there, but what are you not there? Differentiable. Very good. So you're not differentiable there. You are still continuous. Okay, so the correct answer should be C. And do y'all see why it should be C? You've got those 3 points. Awesome. Okay, moving on. Okay, and what about 7? How many times have we seen question 7? A bunch, right? And I keep on giving that just because I want us to make sure we understand what rule is used here. What rule? If we've got the product of 2 things, what rule do we need to use? Product rule, right? We got our product rule. So it's going to be the first times the derivative of the second. And remember, you would also take the derivative of your angle, but what's the derivative of x? It's just 1, isn't it? Plus the second times the derivative of the first, which is just 1 again. No need to write it. So what is our correct answer choice here? It's going to be, it looks like it's B, isn't it? Groovy? Good? All right, moving on. All right, now what about number 8? Which of the following statements is false? Make sure you realize it is false. And it's a limit. And remember, with the limits, you have to be approaching the same value from the left and right. And notice I say approaching, not necessarily equal to. You are approaching the same value. As you creep in toward x from the left and right, your y values must be approaching the same thing. Now, let's look at A. A lot of people chose A because here at this point, you're not continuous, are you? And a lot of people want to choose that and say, okay, my limit doesn't exist there. Can your limit exist there? Absolutely. You're just not continuous. But your limit will exist. So keeping that in mind, what should be the correct answer here? C, right? Because if I approach 4, if I approach the x value of 4 from the left and from the right, are my y values approaching the same thing? No. So the correct answer here should be C. C is false. All right.